probability distribution of discrete random variables. Example problem. A fair coin is tossed twice. Let x be the number of heads observed. Construct a table of distribution of x and find the probability of at least one head is observed. So please watch carefully on how I solve the problem.
So the first row will be the values of x, and the second row for the p of x, or the probability of x. Now, how are we going to solve the values of x? So, in tossing a coin, in the first toss, you may have head. Second toss, head. This is your first try. That is head, head. Second try, you may have head, tail. For the third try, you may have tail, head. And for the fourth try, you may have tail, tail. The question is, can you have the fifth try? What would it be? The answer is no, because if you have the fifth try in tossing the coin twice, you may return to this head, 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 tail, tail, head, and tail, tail. So therefore, there are only four possible outcomes in tossing a coin twice. So what are the values of x? Take note, x is the number of heads observed. So in the first try, how many heads are observed? There are two. How about in the second try? One. Third try, one. And in the fourth try, none. So you have to write 0. So we can conclude that the number of heads observed, or the values of x, are 0, 1, and 2. So these values should be written on the table here, 0, 1, and 2. Okay, let's continue. Let's solve for the p of x. So we will use the data here in solving the p of x, the probability of x. So if x is 0, what is the probability of getting 0? So out of 4 outcomes, that is 1, 2, 3, 4, there is only 1 0 here. So that means out of 4, you have a chance of 1 over 4. That is 1/4. In decimal number, that is 0.25. So what is the chance or probability of getting 1 as the number of heads? So there are 2 ones here. So 2 out of 4. 2 out of 4, that is 2/4, or 1/2. In decimal number, that is 0.5. So how about the probability of getting 2? So you have here 1. 1 out of 4. The same with 0. That is 1 out of 4, or 1/4. In decimal number, that is 0.25. So you have to add the values of p of x. So 1/4 plus 2/4 plus 1/4, the result is 1. So check your answer by using the decimal numbers. 0.25. 0.25 plus 0.25 is 0.5. 0.5 plus 0.5, that is 1. So p of x is 1. If you have your p of x is 1, that means your solution, your computation is correct. If it is not equal to 1, that means you need to recompute, because there's something wrong with your computation if your p of x is not 1. The total of these values of p of x, it should be equal to 1. Now let's solve the second problem. Find the probability that at least one head is observed. So we're done. This is for A. And for B, we are going to solve the probability that at least one head is observed. So from the table, at least one, that means x is greater than or equal to 1. So what are the values of x here that is greater than or equal to 1? So it starts from here. So these are the values of x, and we get the probability of x for that values of x. So p of x, where x is greater than or equal to 1, is equal to your p of x, where x is 1, your p of x, where x is 2. That is p of 1 plus p of 2. And you have to write down here the values of your p of 1. What is your p of 1? That is 0.5, plus your p of 2 is 0.25. So add the 2, that is 0.75. This is your probability of getting x is greater than or equal to 1. So you can conclude that 75% chances or probability that you can have, or you can get at least one head in tossing a coin twice.